This is how to solve systems of equations by elimination. This is section 7.3. This is actually my preferred method in the end. You'll learn more about that when we go to 7.4 as well, because it's only useful if your variables have the same quantity. So for example, I have 2x plus 3y equals 11, negative 2x plus 5y equals 13. Well, I recognize that if I add these two equations, a 2x minus a 2x is 0. That's the idea of elimination. I've just eliminated one variable. And 3y plus 5y is 8y. And 11 plus 13 is 24. And now I can just divide by 8, and y equals 3. Now remember me talking about how sometimes it's easier on the front side, but then you have to do more work on the back side. Well, now that I know y is 3, I can plug it into either one of these equations. It doesn't really matter. I'll pick the first one, and I'll say 2x plus 3 times 3 equals 11. So 2x plus 9 equals 11. 2x equals 2. So x equals 1. So my solution should be 1, 3. And again, 2 plus 9 is 11. That checks. And negative 2 plus 15 is 13. That checks. I'm just plugging these values in and checking the math. So it's pretty simple. Since these guys are opposite, I could add and eliminate one variable. Again, we can only solve for one variable at a time. So when we substituted, we put one variable in terms of the other, so we got down to one variable. In this case, we add or subtract, you'll see, to eliminate a variable and then continue. So let's do this one. This is example 2 on page 445. Well, since these both have the same sign, if I added them, I'd get 6y. These don't have the same quantity, so I can't do anything with those. So instead, I'm going to subtract. So 4x minus 5y is negative 1x, and then 3y minus 3y is 0. And be careful here, 2 minus a negative 2. I like to do this. I follow them with my pencil. 2 minus negative 2 becomes 2 plus 2, so that's 4. So negative 1x equals 4. I have to divide by negative 1, so x equals negative 4. And again, I can pick either one of these equations to plug into. So 4 times negative 4 plus 3y equals 2. Then just simplify. Then work to get y by itself. So my point of intersection should be negative 4, 6. So 4 times negative 4 is negative 16, plus 18 is 2. That checks. Negative 20 plus 18 is negative 2. That checks. So this checks in both of those equations. And then one more. So in this case, things aren't all lined up. So I want things lined up. So I'm going to go ahead and subtract 3x from both sides of this equation. And then I'm going to get negative 3x plus 4y, that's a positive 4y, equals 14. So if this was my equation 1 and that's my equation 2, this is my new equation 2. So now I can write 8x minus 4y equals negative 4. And then I can come back up here and just rearrange so everybody's in a nice order. These guys are opposite signs, so I'm going to add 8 minus a 3x is a 5x, a negative 4 plus a 4 is eliminated, and a negative 4 plus 14 is 10. X equals 2. Come back over here, and I might as well, since this is right here, plug it into this one for convenience. Negative 3 times 2 plus 4y equals 14. Work to get y by itself. Oops, there you go. So 2 comma 5. So let's go back to the originals. 8 times 2 is 16, minus 4 times 5, 20. 16 minus 20 is negative 4. That checks. 3 times 2 is 6. 6 plus 14 is 20. 4 times 5 is 20. That checks. So elimination. If you have variables with the same quantity, you can either subtract them to eliminate, or if they have opposite signs, you can add them to eliminate one. And then once you find one, you just have to go back and plug it into one of the equations to find the other. So that's elimination, and we're going to work on that a little bit more in the future because there's more we can do with elimination.